Okay, welcome back. Today we're going to talk about aircraft rigging and how to get the aircraft to fly straight and level without a heavy wing. It's a common issue on first flights, and the first thing I'll say about it is don't worry about it for the first few flights. Just try and quantify it during the flight testing, and then we'll go through some fixes of how to do that. But what we're going to cover here is how we can do our best to prevent that during the build process. So it's not an uncommon thing to have a heavy wing, as long as it's not seriously affecting the flying characteristics of the plane. I just recommend that you deal with it for the first few flights and then do the fixes that we'll talk about here. And also, the other thing you want to consider is if you have a side-by-side RV and you have a heavy left wing and you're sitting in the left seat and you burn all the fuel in the right tank, then obviously the aircraft's going to have a tendency to turn to the left. So make sure that you're not imparting any imbalance to the aircraft depending on the seating arrangement. Of course, with the RV8, we sit centerline and then trying to keep the fuel balanced during the flight so that we can actually quantify where the aircraft flies straight and level. All right, so during the build process, how do we give ourselves the best chance of the aircraft flying true without a heavy wing? And a lot of stuff affects that. So if we think about setting the angle incidence of the wing, we think about the flaps, we think about the ailerons, the wing tips, the fairings, mounting the horizontal stab, mounting the elevators, mounting the vertical stab. There's lots of stuff that's going to affect the stability, the lateral stability of the airplane. So where do we start? Well, when we're building the aircraft, one of the first major things that we're going to do is attach the tail. And when we attach the horizontal stab, we're going to measure very accurately from a specific point on the vertical stab to a point up on front of the fuselage, making sure that we have a triangular measurement that comes from the fuselage back to a point. And obviously you want to make sure that you use the exact same measurement on each side. So I like to choose a specific rivet and put a circle around it with a marker so that you know which one it is, and then using the same reference on the front. So one thing you want to be careful of is when you're using a tape measure to do this, you want to use, I like to use the same tape measure on both sides, or at least the same brand of tape measure on both sides, so you're not having any variation. The other thing you have to be careful of is often on a tape measure, you're using either the left or the right side of the tape measure. So if you think about it, you measure down the left side of the fuselage to the far rivet, you're measuring on the outside of the tape measure, and then you bring that tape measure to the right side of the airplane, now you're measuring on the inside. So you can impart a little bit of an error there. So you want to be careful that you're measuring exactly the same on both sides, even though you're using the same tape measure. Hopefully that makes sense. All right, so taking your time there, mounting the horizontal stab. So there's step one. Step two, same thing, doing that with the vertical stab. So making sure that you're getting the left or right accurate, making sure that you're lining it up with the center of the fuselage or whatever the build plans call for. If there's any offset on mine, it's just straight. And then take your time with the vertical stab, and that will hopefully prevent us from causing any roll movement when we're flying. So that one's fairly straightforward. Here's the challenging one, is elevators. So how to get these bolted and drilled to each other accurately so that we don't have, when this one is perfectly flush with the horizontal stab, the other one doesn't have any pitch up in it. So we can see on this side here that it's nice and flush, and then on the other side, after it's all drilled, this one should be nice and flush as well. And that can be challenging to do. And if you mess that up, it's going to be very frustrating. So how do we do the elevators? So what I recommend is, usually in the plans, at least on the RV, it will give you a dimension from the corner of the control horn, the steel control horn. It'll give you a measurement of where the hole is located. That hole is not going to be the same on the other elevator. So you only drill one. So you drill that one hole, and I recommend using just a number 40 drill bit. And we're going to drill where the push rod is going to then connect to the control horns on the elevator. Once we've done that, we're going to clamp everything in place. So we're going to clamp the horizontal stab and the elevator together on this side. So something as simple as a big clamp like that. And you can also make sure it doesn't move by putting little strips of aluminum on here as well. So clamping that side, and then of course you would clamp this side as well, because you want to prevent that from moving since one side is not drilled yet. So we have one side of the elevator drilled with a number 40 drill bit, and now we all have it clamped securely to the horizontal stab. And now we're going to drill the other one. But this process of drilling this second elevator, you have to be very careful here, because you need the drill to go perpendicular through the part and then into the other control horn. And a good way to make this accurate, and I'll show you the little tool that I had made here. So this is what I'm talking about. One is steel, one is aluminum. I think the steel one I had made for an RV6 and the aluminum one I had made for the RV8, and they are actually different thicknesses. If you look here, if I hold them up, they are actually different thicknesses. And then I got the machine company to drill a number 30 hole through the center of these pieces. So what are these? These are perfect machine blocks that are going to fill the gap between the control horns where eventually the control rod ends are going to go. So if I show you with a little drill bit here, take a number 40 drill bit, you see how that fits nicely in there, very snug. All right, so how do we use this? Well, we've already drilled the number 40 hole on that side, so then we would enlarge that to a number 30, and then we're going to put this block in between the two steel control horns coming off the elevator, and that's going to fill the gap, and that's going to make sure that our drill bit stays perfect perpendicular to the second part. All right, you can even, once this is in place, you can even clamp the two control horns together to make sure nothing moves. So then the drill bit goes through the hole that we've drilled already, it goes through this block, and then it marks the hole on the other side of the control. Wow. Now when you drill that hole, I actually don't go all the way through the control horn. All I do is the 30 drill bit through the control horn, through the blocker piece, and just enough to mark where the hole is going to be on the second control horn, and then I take the elevator off and drill that full size to number 30. Because if you go number 30 drill bit, you go through this, you hit the second control horn, it's steel, so when the drill bit on steel, it tends to vibrate or rub a little bit, even though that's going to be clamped in there. So I just drill it enough to mark where I know the hole is going to be, and then I take it out and I drill it on the workbench, and it's much more accurate. Again, assembling it all together, making sure that nothing is moved, and then enlarging those holes to a number 12 drill bit using a unibit. And now we get onto the wings. For the RV wings, the spar bolts, of course, are already drilled and fitted, and they're close tolerance. So we're going to use regular size bolts initially when we're drilling the rear spar. We're not going to use the close tolerance bolts right away because they are very difficult to get in and out, as they should be. And this is the time where you really want to take your time, level the aircraft, of course, follow the instructions of the company, and get the wings on. So you really only need about 4 bolts on each side. There's 8 bolts on the main spar of the RV8. And you can get away with just 4 as far as rigging the wings before final fit. So I usually do the 2 big top ones, 7/16 I think bolts, 2 in the top, 2 in the bottom. And then now it's going to be up to us to drill the rear spar hole. And this is where we're going to really take our time leveling the aircraft. A couple tricks here. Again, like I said, when measuring the horizontal stab, using the same tape measure, we want to have that theory when we're drilling the rear spar as well, that we always want to measure the level or the distance at the same part. So what I mean by that is when we take a level, and I like to use a digital level and a bubble level together. So when we're leveling the fuselage, we want it to be level side to side and front to back. So obviously the tail is going to have to be picked up quite far and probably sit on kind of a desk or something about that height. And when it's all level, you always want to measure from the same spot. So you lift the tail up until this is going to read 0. Right now it's 11.3 degrees. You're going to lift the tail up until it reads 0. And actually this is kind of nice because you can put a beeper on it. So you don't have to come back and check all the time. You can just lift the tail up all the way till you hear the beep. So what I mean by that is, where am I going to measure from? All right, well, I'm going to circle this rivet and circle this rivet. And anytime I'm going to measure the level of the fuselage, I'm going to put the front edge on that rivet. Why do I do that? Because right now I come here and be okay, 11.2 degrees. All right, then I come back and it's like, okay, I want to level the fuselage again. So I'm going to measure from up here. And you see it's 11.5 degrees, right? So depending on where you put the level, it's going to change the angle a little bit. So you want to be careful and always measure from the same spot. Same when you're setting the angle of incidence of the wing. You're going to put a level on the wing. You're going to put a 2-inch block, at least for the RV8, on the rear spar. And then you're going to make that so it reads 0. So what I use is so I use this big level. It's a 4-foot level. So that level is going to butt up to this rivet line right here. And then we're going to put a 2-inch spacer on this rivet line. And then when the front of the level sits on that rivet line, and then you have the 2-inch spacer on the back, then that should read level with, of course, the fuselage level. So pretty easy to do. And what I recommend is, again, use the same level on both sides of the aircraft. Use the same 2-inch block. All right, you don't need 2 blocks for this. It's 1 wing setting at a time. But we don't want any variation on those blocks. So we're going to take our 2-inch wooden block, do the left side of the wing. We're going to use that same block and do the right side of the wing instead of manufacturing 2 of them, because they're not going to be perfectly identical. Also, measuring on the same side of both wings. So if you're going to measure on this rib, on this wing, you're going to measure the exact same thing on the other wing. And this is where you're going to take your time for the sweep back and forth of the wing, and it's going to be fairly close. I'm going to tell you that right now. That is not the area where you're going to have to make big adjustments, because these kits are very well made and those spar bolts are pre-drilled. So it's actually a pretty easy thing to do. But you're going to level the fuselage. You're going to run a laser line. So it's another recommendation I have when you do this. Buy yourself a laser level and buy yourself a good one. Again, $300-400 laser level is going to pay for itself to get this done accurately. So don't use the cheap one from whatever the names of those companies are out there. Get the good one. Get the expensive one that has the auto leveling and the 2 crosshairs, the horizontal and the vertical on it. All right, so think of that, $400, maybe $500 for a good laser level. Would you pay somebody $500 to perfectly rig your aircraft for you? Probably. So get yourself a good tool that's going to help you out a lot. So using that laser level, I have a DeWalt one. Once the aircraft is all leveled, I'm then going to put the laser level in front of the aircraft and run a laser line down the center of the fuselage. So how you're going to see that is you put the laser level on the floor, and then it's going to shine up on the belly, and you're going to use the rivet line down the center of the belly to run a line there. So that's going to have a line on the fuselage. It's also going to have a line on your hangar floor or wherever you're building. And then I go along and I trace that line with a marker. So you're actually going to draw a line on the hangar floor. And it'll be a nice nostalgic line later on when you're looking at your hangar and you see here the marker on this one. We got the line going down center here, and then there's the 90-degree line that we use to line up the wings. All right, so now we got a line going down the center of the fuselage. We're going to move the laser level down the side and look down the wing line, and we're going to hang plumb bobs off the front and make sure that the wings are 90 degrees to the fuselage. And again, take your time here, measure it accurately, and you will be surprised at how good you can get it if you take your time. This one ended up being within 1/32 of an inch from wingtip to wingtip, and I don't even think you can measure that accurately, but I'll show you the pictures here to prove it. But take your time, and you can do it very accurately. All right, now for setting the angle of incidence. Again, you're going to have to drill the rear spar. You're going to have to make sure you have edge distance on all parts, so you're going to take your time. But the rear spar drill, obviously in front of the flap here, you're going to move the wing up or down to have that previously mentioned 0-degree indication on the laser level. And then you're going to clamp the rear spar, and you're going to drill that single hole through the back of it. It's 5/16 inch hole. So that sets your angle of incidence. So if you take your time doing that, now you're off to a good start. Now here's where most of, I believe, the roll tendencies of building these aircraft come from. So we got the wings bolted in place, and now we're going to put the ailerons and the flaps on. And I've seen in other videos where the wings are on a cradle, like you see behind me here. These are RV-10 wings. So you see the person attaching the wingtip while the wing is in the cradle there. So don't do that. Don't attach the wingtip while the wing is not on the plane. Because I believe it's the wingtip that causes a lot of the roll tendency. So how do we do this? Once we have the wings bolted in place, we're going to put the flaps on. At a neutral position, and again defined in the plans of your aircraft, this flap would obviously be up. I'll move it up here in a second. We're going to make sure that when the flap contacts the fuselage, that it does so in exactly the same spot on both the left and the right. So you're going to mark a little rivet. Where does this trailing edge end up being? And then you're going to make sure that that's exactly the same on the left-hand side, so that we don't have one flap lower than the other, which of course is going to make the aircraft bank when you fly. Okay? Again, all this stuff can be corrected later, but this is where we want to be as careful as we can, because when we set that reference the fuselage, we're then going to use that reference for the aileron, and then we're going to use that reference for the wingtip. One thing we didn't mention is when you're building these control surfaces, you want to make sure that you don't impart any twist in them. So it mentions that in the plans. It tells you how to do it. Make sure it's on a flat surface, a good workbench, a nice clean new sheet of plywood down perhaps, so that when you're building these control surfaces, we don't end up with any twist. All right, so very important. So let's bring the flaps up on this thing. Okay, so here we are. We've decided that this is the neutral position of the flaps. Of course, you're going to have some way to hold it in place here because the control rod's not going to be connected. So when you let go of this, obviously it's going to fall down. So this fairing actually won't be on while you're doing this. So you'll be able to see in here. And when you look at where it meets the fuselage, you're going to make sure that it's the same on the left and the right. So you can see that this is fairly flush here. And then I'm going to adjust the flap on the other side to make sure that it is the same. And this is a fairly easy thing to do because you can adjust the push rod. So you see on the right side that side is also nice and flush with the fuselage. And then we're going to connect the actual push rod for the flaps. So attach the push rod, attach it to the motor, obviously, and then make sure that the flap on each side is indicating the exact same spot referenced the fuselage. If one's a little higher, then just adjust the length of the control rod by threading in the control rod eye bolts to get perfect on both sides. So those are the flaps done. We've aligned it with the fuselage at the exact same spot on each side. Now we put on the ailerons. When we put on the ailerons, we don't have to have those connected to the control rod yet. We just have to have the bolts attached to the push rods. So we have the flaps in an up position. We got the control rods connected and they're all installed. Now we're going to put the ailerons on and we're going to clamp the aileron to the flap. And you're going to clamp it on the other side as well. All right, so you clamp the aileron to the flap on both sides. And then you're going to adjust the length of the control rods so that the attached bolts just nicely slip in. And when you take the clamp off, the aileron should stay real nice and level with the flap. So you got a nice, you have a nice edge that way, and you have a nice edge this way. Another thing you can do besides using those clamps, and this is one thing that I like to do actually, and I'll show you this on the wingtip, but if you take some little pieces of aluminum, here, this is just a piece of aluminum, and you could actually drill out a rivet on the aileron, drill out a rivet on the flap, and actually cleco these two things together. And that'll hold it really nice and secure if you want to do more than just clamp the trailing edge. But clamping the trailing edge works fairly well on this. So that's how we get the aileron to perfectly match the flap. Now here's the key, the wingtips. So now the wings are on the aircraft. Now is the time to drill the wingtips. So we put the wingtips in place. They actually fit quite nice all the way around. It's all very reasonable fit. I've not had any issues with the wingtips on any of the RVs, except this area here where you see all the primer. It tends to sit a little bit high. It tends to bow a little bit because there's no filler in the middle here when you first attach the wingtip. It's up to you to put a rib in there. And you don't want to put that rib in there at the start. You want to put it in after you've aligned the flaps and the aileron. And now we're going to cut the trailing edge of the wingtip, and it's going to be quite thick fiberglass here, so you're going to have to cut with a Dremel tool, just kind of split the trailing edge here. You can get away with not cutting the whole trailing edge. you could probably get away with just cutting about half of it, just to get this to kind of open up. Now you're going to take some aluminum blocks with some number 40 holes drilled in it. We're going to remove 2 of the rivets on the top of the aileron and 2 of the rivets on the bottom. And we're going to cleco the aluminum angle to the aileron, and then we're going to drill number 40 hole into the wingtip. And we're going to put 1 clamp here, 1 clamp here, and then 2 of those on the bottom as well. And now that's going to ensure that our wingtip is perfectly aligned with our aileron. Then we're going to take a file or a sanding block and sand down the trailing edge to match the trailing edge of the aileron here. While that's all clecoed together, we're then going to go back and we're going to fill in this fiberglass edge with some epoxy and some flux and rebuild the trailing edge. And then once that dries, this trailing edge is going to match up perfectly to our aileron. And how do we keep this from bowing? So we have our aluminum clip here, and we have our aluminum clip here. Now what we're going to do is fill in the inside of this. There is actually an aluminum rib that you can put in here. I don't recommend it. I recommend just using fiberglass because the aluminum rib doesn't tend to fit properly in my experience. So I recommend filling it in with fiberglass. So while these angles are here, we're going to take some strips of fiberglass, and they're going to be dried fiberglass already. So just lay out some flat pieces of fiberglass and add some epoxy to them so that you end up with strips of fiberglass that kind of look like this. This is aluminum, which is I'm going to show you just for effect here. But now you have a dried piece of fiberglass like this. And we're going to take those dry piece of fiberglass and we're going to put them in here. And you can just use a weight or a bucking bar or something behind it to push it against the wingtip. So we want it to be flat against the wingtip. And then now you put a little bead of epoxy here and a little bead of epoxy on the bottom. And now you've bonded this fiberglass strip to the wingtip. So 2 is enough. So put 1 strip here and maybe 1 strip here, or maybe on the other side of that. So now it's going to hold the wingtip inside edge from bowing out here. Now after we've done that, we can then take the wing off. These pieces will be bonded in place. Take the wingtip off, take our aluminum angles off. And now we'll take the whole wingtip off, and inside of the wing, we're then going to add fiberglass rib in there. And when it's all said and done and you have that fiberglass rib in there and it's nicely aligned, then these things you can just cut off because they're just there to hold the wingtip in place as we create that rib in the inside. So what you'll end up with is a really nice match with the aileron on the outside and also a nice wingtip match of the aileron on the top and on the bottom. So I think that does a lot to not impart any roll tendencies for the aircraft. So if this wingtip sits up a little bit, that one sits down a little bit, obviously it's going to have a tendency to roll to the right or vice versa. Okay? So that's everything that we've gone through to give yourself the best effort that the aircraft is not going to have a roll tendency. Now, if it does have a roll tendency, we're just going to suck it up for the first few flights. Don't worry about fixing it on the first few test flights because we for sure want to quantify it before we start measuring anything. And again, like I mentioned before, make sure it's not you sitting in the left seat. Make sure it's not a fuel imbalance or something that you can control. So now you're flying, you got a few hours on the plane, and it still has a slight tendency to roll to the left. Well, there's documentation from the company of how to deal with this. The first thing that I recommend is seeing if the roll tendency can be fixed with rudder trim. So when we're flying, We'll have a ball in the cockpit, and I actually use this very simple setup when I do my test flying. Just a very simple yaw indicator. And I'm going to make sure that the aircraft is level side to side on the ground. And then I'm going to use double-sided tape to put this gauge. I don't want to keep this gauge in the cockpit because it's super ugly. And then once I figure out the rudder trim, then I can take it off. So I want to make sure that the roll tendency of the aircraft isn't due to just rudder trim. So level the aircraft side to side, double side tape mount this so that it reads exactly 0, and then go flying and see if it's out. And slightly press on the ball to see if you can get it to center and see if that takes away your heavy wing. So if that's the case, then obviously you just need a little bit of rudder trim. You're going to get a rudder trim tab and put it on the appropriate side of the rudder, and then test fly it again and see if that fixes it. So that could be the simplest way of fixing the roll tendency of your airplane. The other thing you want to do is go back, make sure that the flaps are the same on both sides, make sure the ailerons match the flaps, make sure the wingtips are aligned to the aileron, and that nothing has changed or moved during the first few flights. After that, what you can do is start messing with the trailing edge of the control surfaces. And there's documentation on how to deal with this, but essentially you're going to pinch the control surface a little bit, I believe, on the light wing, but make sure you read the documentation from the company on how to deal with that. Now, when I say pinch, it's using a pair of hand seamers to just ever so slightly modify the trailing edge radius of the aileron. It's not going to be visible after you've done it. So messing with that for a little bit, and then that should help you. A few iteration processes of that should help you fix your heavy wing. So hopefully that helps you on your build. Remember, as far as rigging the aircraft and getting it to fly straight, it's all about accurate tools and accurate measurements. So beg or borrow a nice laser level to get the nice measurements for the wing sweep and the angle of incidence. Taking your time mounting the horizontal stab, get yourself a little spacer tool made for the elevator. Make sure the vertical stab is on accurately. Taking your time and measuring the sweep of the wings, and then drilling the rear spar, and then working from the fuselage out, getting the flaps perfectly aligned with the fuselage, aligning the ailerons with the flaps, making sure both of those don't have any twist built into them. And then the last thing, and probably the most important one, is making sure that the wingtip is not creating any roll tendency for the aircraft. So there you go. And that should fly straight and level. The last thing that you're going to worry about, and this is why I recommend test flying without wheel pants on, is that the wheel pants are like little rudders. So you want to make sure those are aligned properly as well. So again, having a laser level down the front of the airplane, having a plumb bob off the front of the wheel pant and the back of the wheel pant, and then making sure that is parallel to the center of the fuselage so that we don't impart any yaw into the aircraft due to just wheel pants. Of course, I don't have to worry about gear fairings on this one because they're solid aluminum on this 8. So I hope that helps you guys. Build yourself something, take it for a rip. Hopefully it's straight and true, and see you guys on the next video. Cheers.